Hi everyone. This is for your chemical reactions notes, your INB pages 14 and 15. Hopefully you've already taken this document from Schoology and put this into your into Notability across pages 14 and 15 so that you can then take notes on it as you're watching this video. Obviously, if you need to pause and write notes or whatever you need to do, that's fine. And take your time through it. But you should be able to finish it by the end of class. And if you don't, you definitely need to finish that for homework in addition to the review packet, because don't forget that your test is going to be coming up at the end of the week. All right. So I am going to start, on page 15. And the essential question is, what can happen when atoms and molecules interact? And we've already talked about this quite a bit, but we're getting deeper into the fact that when they do interact, they exchange electrons and chemical reactions occur. So, all right, I am looking again at page 15 and the very first chunk of information at the top of page 15 underneath the essential question. And it says chemical formulas and names right here. And I'm going to give you some notes to fill in. So first off, it says compounds are, and this should say two or more elements bonded together to form new, let me write that in here. So two or more elements bonded together to form a new substance with its own properties separate from the elements that make it up. Secondly, compounds can be represented by a chemical formula. So let's write that in. Chemical formula. And it's hard to write on this recording device. So sorry about the writing being kind of messy on here. So compounds can be represented by a chemical formula. Thirdly, a subscript tells you the ratio of elements in the compound. So subscript. Sorry, I'm running out of room. A subscript tells you the ratio of elements in the compound. For example, in MgCl2, which is magnesium chloride, the ratio of magnesium atoms to chloride atoms is 1 to 2. If there is no subscript after, meaning after an element, then the number 1 is understood. So I'm going to do some examples down here, and I know this isn't in your notes, so you can just follow along. So in this first one, it says C6H12O6. That, by the way, is the chemical formula for one molecule of glucose. So what this means is that there are 6 carbons, there are 12 hydrogens, and that there are 6 oxygens. Pretty simple. So that subscript in each case tells us how many of each of that element or each type of that atom that there are in one molecule. So this whole molecule is one molecule, but that's how many atoms are in that one molecule. Okay. Next, NaCl, sodium chloride, that is table salt. So Na, there's no number after it. So that means that there is only one sodium atom in the molecule, and there's no number after the chloride right there. So there's only one chloride. That's what that is. So there's one sodium and one chloride. All right, if you go over to page 14, the very first block at the top. It's practice. We're going to fill this in. I'll fill a couple in together, and then we can go over it together in class on Thursday. So how many of each type of atom are in each of these chemical formulas? So for instance, in H2O, H2, so that subscript after the, let me get my pointer, that subscript right there after the H, so a subscript is that little number after the element symbol. Okay, sorry, you hear the baby screaming in the background. Sorry about that. So that means that there are 2 hydrogens, and there is no number after the oxygen right there, which means that there's only 1 atom of oxygen. So there you go. There's 2 hydrogens and there's 1 oxygen. I will let you fill the rest of this in, and we will go over that on Thursday, and we will move on to the rest of the notes. Okay, now we're switching back to page 15, the second group on the page, second chunk of notes, and we are looking at whether or not there's a big number in front of the chemical formula. So, and some examples would be like here, if it said like 4H2O2 or 6H2O. So what does that big number mean? So to get started, that big number is called it's called a coefficient. And again, I'm sorry about my stylus here. A coefficient. All right, so a coefficient, I'm being lazy, I'm sorry. The coefficient represents how many of that molecule there is. So for example, 2H2O means that there are 2 molecules of H2O. That would be 2 water molecules. So as a reminder, subscripts tell you how many of an atom or element is in a formula. A coefficient tells you how many of a molecule, I'm going to abbreviate there, of a molecule is in a formula. So looking down here at the bottom in my examples, so down here again, this means that there are, let me get my pencil out, it means that there are 4 H2O2s. By the way, H2O2 is hydrogen peroxide. That stuff that sometimes you put it on cuts and it bubbles up. You stick it on cuts to kill germs. That's hydrogen peroxide. So this would mean that there are 4 hydrogen peroxide molecules there. And 1 hydrogen peroxide molecule consists of 2 hydrogen atoms and 2 oxygen atoms. All right. In another example over here, we have 6H2O. That means 6 water molecules. So it means 6 water molecules. Okay. And of course, a water molecule, like we said a few minutes ago, means, or rather it has 2 hydrogens and only 1 oxygen atom in that 1 molecule. Okay, so now to do the practice for this, going back over to page 14, the second group, we're going to do the practice for this, looking at the coefficients. So I'll do the first one with you again, and then you can do the rest, and we'll go over that on Thursday as well. So, examples. So looking at the first column over on the left here, it says 2H2O. So how many H's are there? All right, so if you look, 2 H2O. We know that there are 2 H's in one molecule, but there's 2 total molecules. So you're actually going to just multiply. 2 times 2 is 4. Oops, get my pencil back here. So there's 4 hydrogens in that case. Oxygens, remember there's only 1 oxygen in a water molecule, so 2 times 1, so there's 2 oxygen molecules in there. So let me show you. If I have H2O and H2O, okay, if you count up all the H2s, that means I have 4 H's and I have 2 oxygens. Okay, so that's where I get that from. So I want you to work on the rest, try it out, see what you come up with. And like I said, we'll go over it on Thursday. Okay, last section of notes on page 15, the third group. What are chemical equations? So a chemical equation, so I'm up here, a chemical equation is a short, easy way to show a chemical reaction using symbols instead of words. For example, H2 plus O yields, so that arrow means yields. H2 plus O yields H2O. So that's an example of a chemical equation. So the structure of an equation. So there's a structure to it. Okay. First bullet. The substances you have at the beginning of the reaction are called the reactants. The reactants. The new substances that you have at the end of the reaction are called the products. So the general plan for the chemical equation is reactant plus reactant gives product plus product. And I gave an example down at the bottom here that's, again, not in your notes unless you want to draw it in. It's so the reactants, if I were baking a cake, would be a reactant would be eggs and cake mix and oil that would yield a chocolate cake, yum, minus the frosting, of course, just pretend the frosting's not there, and carbon dioxide bubbles, because that's what's created when you bake a cake. That's what causes all those little holes in the cake. So those are the products. So I have reactant plus reactant plus reactant, in this case, yields product plus product. Okay, so let's go back over. So again, we're back at the practice on page 14, the third group down. And I'll do the first one with you again, and then again on Thursday, we will go over the answers together. So it says in the following chemical equation, list the products and the reactants. So number 1, CaCO3, which is calcium carbonate, yields CaO plus carbon dioxide, calcium oxide plus carbon dioxide. So the reactants are on the left-hand side of the arrow. So those are the ingredients. So this would be CaCO3. I'm sorry about my pen. Ugh. The products, try to fix this here. CaO plus CO2. So that's pretty easy. Again, you just have the left side is the reactant and the right side is the product. That's all. And that's all, folks, for that one. And I wanted to quickly show you an example. Give this a second. okay, of a chemical reaction using the using symbols instead of the letters. So I pulled up a website here, and okay, I have my pen. All right, so over here I have 6 hydrogen molecules. But what this, if I were to write this out, this would be 3H2 because they're connected. It's kind of hard to tell that, but so there's 3H2 plus, and this is actually wrong. That says 1 hydrogen molecule. It's supposed to be 2 nitrogen. So, but that's connected. So plus N2, and there's only one of those molecules. And that yields 2 ammonia molecules.